Hi, good evening, friends. Uh, I welcome you to the day 4 of the workshop on biostatistics. And it's surprising that we are already into the fourth week and we have finished the fourth week and we are starting the fifth week. And I hope that these sessions in the last few weeks have been helpful and interesting to you. And I hope that you have been able to pick up some new things as a part of this workshop. So for today's program, what we have a plan for today's is that in between 6 and 6:30, we will just have an informal discussion on the weeks gone by. We will talk about the solutions to the exercises that were given in week 3. We will be talking about the modeling of logistic regression models and the pitfalls in logistic regression between 6:30 and 7 when Dr. Debapriyo Chakrabarti, who's a Fulbright scholar and working as a biostatistics expert in France, will be talking to you about modeling and pitfalls. Between 7 and 7:25, we will have a do-it-yourself in-class exercise. The session would be led by Dr. Amir here. And between 7:25 and 7:40, we will have a presentation of a journal article which reports logistic regression, and we will try and relate it with the session which was recorded and posted and was shared with you all earlier, and how that session relates to how it is presented in a written manuscript. This session would be led by Dr. Shailaja, and between 7:40 and 8:30, we will have a live discussion uh, with Professor Marie Diener West, who will join us live from Johns Hopkins, and where you are welcome to ask your questions. Mostly with foreign faculty, it's always advisable. The more you ask them and more you engage them, the better the session becomes, and it becomes more worthwhile than asking them to give a didactic presentation. So I'll just go on to last week's questions and assignments. We had the first assignment, which was to prepare your do file and improve your do file. So the first was to include the commands in your do file and to clear the working memory and start a log file. The next was to import the modified class data into your stata, then to run a codebook, describe, and summary command. The next was to draw a scatter diagram for the number of publications of each participant and relate it to the years of experience and describe it by sex. So we will look at how that was to be done, but I hopefully feel that some of you or most of you would have been able to do it. The next was to repeat step 4. That means to draw a scatter diagram of the number of publications with the years of experience and segregate it by designation. Number 6 was to repeat the exercise in 4 by using the segregation between teaching as a hobby, between those who had teaching as a hobby and those who did not. The next was to save the figures and then to close the log file. We will see the answers to this assignment in a little bit. The next assignment was to identify what are the factors associated with the number of publications of participants. So what is the dependent variable here? What variables would you like to include in your model as independent variables? Then you were asked to develop a model in your group after discussing reasons for including each covariate. And then you had to identify one key predictor variable of interest and report the coefficient beta for all the variables which were found significant. And also, what was the measure of variability explained by your model? So were you able to identify what was the dependent variable? Any responses?
So the dependent variable would be publications.
Yeah, so the number of publications, that's correct, would be the dependent variable. And do you think this is a continuous variable, or is it a categorical variable or a binary variable?
There are two variables. One is just publications and one is categorical one, 1, 2, 3, 4, 5, like previous publications. So I chose the plain publications because that is the continuous one.
Absolutely. So that is very correct. The number of publications was introduced into the data and is a continuous variable, which is to be used as the dependent variable. And then you had to include some independent variables as the predictor variables or covariates. So I had used these three terms differently in the three questions so that you are familiar that we have three different kinds of nomenclature for each. It could be independent, it could be covariate, or it could be predictor. So would you like to elaborate, uh, Dr. Nishad, on the kind of independent variables that you considered and thought to include in your model?
Yeah, so the most obvious predictor would probably be years of experience or probably age, but they are probably going to be multicollinear since the older people probably will have more years of experience. So one of them can definitely be included in the model. Probably years of experience would be better since it counts professional experience rather than the pre graduation years. The other potential predictor was there was some data collected about hobbies, and teaching was one of them. And teaching, an interest in teaching might be predictive of more academic interest and probably more publications also. So that's one thing to consider. Sex is almost always a confounder for many things, but maybe less important here. And designation is a potential predictor, but designation, except for one mention of consultant, it was structured as an ordinal variable. So it was like assistant prof, associate prof, additional, and then prof. So, and student before that, sorry. So, I think most of that would be captured in the years of experience variable, which has the advantage of being a continuous variable. So probably more information in the years of experience. But that said, it depends on the original question. So if our aim was to correlate the designation with the we were looking at the relationship between designation and number of publications, then we should use designation. But otherwise, age of years of experience would be better. Uh, but there are very few observations, around 20, just over 20. So we can't have too many predictors in the model. Maybe just a couple of predictors.
Yeah, thank you. Thank you, Dr. Nishad. That's brilliantly summarized and beautifully summarized about the kinds of independent variables which we would be able to include in the model. As you correctly pointed out, age, designation, and years of experience would have a lot of collinear relationship between them. And so it may not be appropriate to include all of them into the model. But the idea here was to try and identify how to build model and how to get the variables into the model. You were rightly pointing out that one was teaching was a hobby, and so that may affect or impact the number of publications. Similarly, if you had explored it further, you might have found that one hobby which was presented was writing. So it was possible that those who like to write more are likely to present or publish more papers. And if you had explored the model even more, you might have found that there was a variable called number of children. And number of children, incidentally, in this question tries to get an association between a number of children and the publications also. However, we left it to you to identify which variables to include and which not to include. But the learning point here was to discuss, develop, and have a reason why one is there and one is not there. You could identify any key predictor variable, which, like you rightly pointed out, could be designation or could be years of experience, or somebody might want to have a different research question and have a different uh, principal variable of interest. and the others would fall around it. Then you had to report the coefficients. And once you run the regression analysis by using a simple command, regress followed by the number of publications and other variables that you would like to include in your model. So if I try and do it for you live on Stata, what I would do is probably this. If I have this data and I use my do file here to work on this, I could just regress publication with age, and I would get this regression model where the command is regress publications age, and it has given me a model where it's finding that there is a significant p-value here. And so there, as age advances, there is an increase in 1.6 publications per year of advancing age, according to what we have in our data. Supposing we regress it with sex, we will find that we have another model here, which we find that sex is not significantly associated with the number of publications. We could build a multiple regression model by using the command regress publications, age, sex, and designation. And once we run this command, we get a multiple regression model. And we find that probably here, designation is the only important feature, and that is being associated with the number of publications. The others are not significantly associated with the number of publications. So much so for last exercise. And here in the first column, you will have the coefficients of correlation, coefficients of the regression model, about each one telling what is the change in the number of publications with each unit change in age, with each unit change from 0 to 1 in sex, from each unit change in the ordinal variable designation as it has been set up. I introduced only these three into my model, but you could choose to have different models and choose different covariates entering into your model. I will stop here and I will ask Dr. Amir to now lead from here and try and ask and invite questions between the audience and get more of a discussion running.